Well, having missing data is pretty common in data analysis. And in this lecture, I want to talk about a couple R packages that can help us explore the patterns of missing in the data at our hands. So here, let's look at these R codes. I already set my working directory, and next step I'm going to do is to invoke the following package so that I can use the read.dta, this function to reading an external stated data file. Okay, and then next I use subset to select cases and variables to create a subset of the data that I just reading. Okay, and to make things straightforward and my discussion effective, what I'm going to do is I'm just going to keep the first 50 cases of the subsetted data. Okay, so I'm going to keep the first 50 cases using the head function, and below I'm going to show you the data. Right. So in this subset data, we have 7 variables, right? 50 cases, and we have missings in the first variable, happy, right? Quite a few, and then we have uh, one missing, another missing for education variable, right? And what I'm going to do next is to invoke what is called disk tools package, because there are a couple very, very powerful functions we can use to explore the patterns of missing. So require this package, and then we use plot missing. Okay, we click that, and we specify this data frame object, miss DTA here, and the function we use is called plot miss. Okay, so we have data here, and we can zoom in, take a look at it, and all the variables are listed on the y-axis, and here x-axis are their authentic case number from number 1 to 50, right? And corresponding to these case IDs, we have missings, right? And for education, we have roughly 1 missing case. So for happy here on the right of y-axis, we have more detailed information. For example, for this happy variable, we have 16 missing cases, which counts for 32% of the total for happy, right? All other variables don't have missing except education, right? EDUC, which has 1 missing case, which counts for 2%. Okay? To learn more about patterns of missing, we can also use what is called complete columns. It's going to produce the columns of variables actually that don't have any missing cases. So run that line, and it turns out age, female, race, in 1K year don't have any missing. That's exactly um, in line with what we found in the graph, right? The next thing we want to do is, this is probably the most useful function from disk tools to explore missing patterns. It's called count cases. That is, count complete cases. We run this function, and here it has very elaborate uh, uh, information about patterns of missing, right? So total rows 50, because we have 50 cases, right? Complete cases, that is cases that don't have any missing for any of the covariate, 33 cases, which counts for 66% of total. That means if we apply list-wise deletion, that is, if we're going to drop any case that has any missing for any of the covariate, what's left with is going to be 66% of the total, right? And then we can go variable by variable, right? For the first variable, happy, how many missing we have? Well, 16, and the percent, 32%. And if we drop this variable, okay, then the total number of cases without any missing going to be 49, and percent is 98%, corresponding to the drop that I was talking about. For age, total number missing is 0, so 0%. And if we drop age, then if we're gonna look at, so basically this column tells us, if we drop its corresponding variable, kind of specified in this column here, how many cases we're left with that don't have any missing here. So in this case, if we drop age, we're going to left with 33 cases, complete cases without any missing, and that counts for 66%. Okay, and in this case, education. If we drop education, what's going to happen? Well, we're going to be left with 34 cases without any missing, and that counts for 68% of the total. Well, let's continue to try another package. Another package is called MI by Andrew Gellman and his colleagues. And first thing we're going to do is actually we're going to feed this data frame object into a function called missing underscore data dot frame and call outcome MDF. Okay. And we're going to show some patterns. Well, there are lots of information here, and you can read the help file or try this function to figure out. But most of the columns here actually are useful for multiple imputation or missing data imputation. Two columns I think pretty useful would be the first column that tells us, the variable type, roughly speaking, and the second column tells us how many cases are missing for corresponding variable. And we can also use this image function to plot missing pattern, like the plot miss function. And here, I think we can use zoom function to take a closer look. So here are observation numbers, and these variables, again, from happy to year, they're standardized. Remember that they're standardized variables, okay? They're standardized here, right? And they're clustered by missingness. So all the missings are clustered here, for happy, and here for education. Well, again, there are a lot of options and details about these functions that I just went over. So my recommendation is to try these functions and check out their corresponding help files, okay? And experiment with these functions, okay?